This is an introduction to trig. First thing to remember are right triangles and the Pythagorean theorem, where the two legs are A and B, and the sum of the squares of the legs is equal to the hypotenuse squared. So if you were given two sides, A is equal to 5 and B is equal to 9, and you wanted to find out what side C was, 5 squared plus 9 squared is equal to C squared. So 25 plus 81 is equal to C squared. That adds up to 106. So when you take the square root of both sides, then C is equal to the square root of 106. That's if you're trying to find the hypotenuse. If you want to find one of the legs, and you know that side C is equal to 14, and side one of the legs is equal to 10, and you're trying to find the other side, then you would have 10 squared plus the missing side squared is equal to 14 squared. So 100 plus b squared is equal to 196. B squared is equal to 96, so when you take the square root of both sides, b is equal to the square root of 96. To help with Pythagorean theorem, there's something called Pythagorean triples. Three, 4, 5 are three numbers that if you plug them into the Pythagorean theorem would give you a true statement. 5, 12, 13, 8, 15, 17, and 7, 24, 25 are other Pythagorean triples, are all the Pythagorean triples that you can use that are handy. So in other words, if you knew that this was 3, 4, then your hypotenuse would have to be equal to 5 and you wouldn't have to bother with the Pythagorean theorem. Or if you knew that this measure was 10 and this measure was 8, this would have to be 6 because these are all multiples of 3, 4, and 5. So if you take 2 and multiply those, you can see that you get 6, 8, 10, which is another Pythagorean triple that's a multiple of 3, 4, 5. Some more geometry review would be to talk about special right triangles. One of them is a 45, 45, 90 degree right triangle. And if you know the two legs of your right triangle are x because it's an isosceles right triangle, those two sides are equal. If you want to find the hypotenuse, then you could use your Pythagorean theorem, and x squared plus another x squared is equal to c squared. That adds up to give you 2x squared is equal to c squared. So when you take the square root of both sides, c is equal to x the square root of 2. So this missing side over here is going to be x the square root of 2. Another review topic from geometry is when you have an equilateral triangle, all the sides are the same length. We're going to say these sides are 2x. And if you drop an altitude down to the base of your equilateral triangle, then that's going to form a right angle. And all the sides of the equilateral triangle are going to have angles opposite them that are the same. So they're going to be 60 degrees, and this whole angle here would be 60 degrees. So if you focus in on just the 30, 60, 90 degree triangle right here, we can show a relationship that exists for those. But before I can do that, I need to convince you that these two triangles, triangle 1 and triangle 2, are congruent. So again, if you go back to your geometry, You have this side, which is shared by both triangle 1 and triangle 2, and you have the hypotenuse of the two triangles are going to be the same measure because it's an equilateral triangle. Then you know by hypotenuse leg that these two triangles 1 and 2 are congruent. So if they're congruent, then that means these two sides over here are going to be equal because of corresponding parts of congruent triangles. So if that's the case, if the whole side is 2x, that means this side has to be x. So on this other triangle then, if you focus in on the 30, 60, 90 degree triangle, and this angle has to be 30 because it is congruent to this one, that cuts that in half. So you have this relationship, and if you use the Pythagorean theorem, calling this side b, you'd have b squared plus x squared is equal to 2x quantity squared, which is going to be b squared is equal to 4x squared minus an x squared. So b squared is equal to 3x squared. And when you take the square root of both sides, you get this missing side is x the square root of 3. So, in summary, the thing you need to remember here is the Pythagorean theorem, and that you also need to remember for a 45, 45, 90 degree triangle that the relationships of the sides are going to be x for the two legs and then x the square root of 2 for the hypotenuse. And for a 30, 60, 90 degree triangle, you need to remember the relationship, the hypotenuse is double whatever the side that's opposite the 30 degree angle, and the side opposite the 60 degree angle is going to be x the square root of 3. So again, for a 45, 45, 90, the relationship is x, x, and x the square root of 2. For a 30, 60, 90 degree triangle, the relationship is x, x the square root of 3, and 2x. So those relationships you need to remember because we're going to then do trigonometry from this.